In the previous video, we have seen continuous probability distribution. So we'll continue with more questions of continuous probability distribution. So the question is, a random variable x has the following probability density function f of x, which is equal to kx square for x between -3 and +3, 0 elsewhere for other x values. Find k, probability that x will be greater than or equal to 1, less than or equal to 2, probability that x is greater than 1, and the probability that x is less than or equal to 2. So in the question it is said f of x is a probability density function, means f of x will be non-negative for all x values, and integral of this f of x from -infinity to +infinity with respect to x will be equal to 1. So you can make use of these conditions to calculate k value. Since f of x is a probability density function, integral from -infinity to +infinity f of x with respect to x is 1. Now to substitute for f of x will be kx square from -3 to +3. This integral is from -infinity to +infinity. So split this integral into sum of integrals, as integral from -infinity to -3, then integral from -3 to +3, then integral from 3 to infinity. The sum of the three integrals which will be equal to 1. Among these three integrals, if you see the second integral from -3 to +3, in that integral the integrand f of x can be replaced by kx square. And in the remaining two integrals, the integrand f of x will be zeros. So the first and third integrals will be zeros. The remaining integral is integral from -3 to +3 kx square dx, which will be equal to 1. In this integral, k can be kept outside the integral sign. So k into integral from -3 to +3 x square dx will be equal to 1. And x square, integration of x square is x cube by 3. So k into difference of that x cube by 3 at the upper limit 3, at the lower limit -3, which will be equal to 1. K into putting x as the upper limit 3 cube, 27 by 3 means 9, minus putting x as the lower limit -3, -3 cube is -27, by 3 is -9. So minus of -9 will be +9. K into 9 plus 9 is 1, k into 18 is 1, or k will be equal to 1 by 18. Probability that x will be greater than or equal to 1, less than or equal to 2. Probability that x varies in an interval a to b means integral a to b f of x dx. So here it is integral 1 to 2 f of x dx. And since 1 to 2 comes in between -3 and +3, straight away f of x can be replaced by kx square by keeping k outside the integral sign. And k is 1 by 18. Integral of x square is x cube by 3. Difference at the upper and lower limit 2 and 1. So 1 by 18 into putting x as the upper limit 2 cube is 8 by 3, minus putting x as the lower limit 1 by 3. 1 by 18 into 8 by 3 minus 1 by 3 means it is 7 by 3. So 7 divided by 18 into 3 is 54. Probability that x varies in the interval 1 2. Probability that x will be greater than or equal to 1, less than or equal to 2 is 7 by 54. Similarly, probability that x is greater than 1. X is greater than 1 means the lower limit will be 1, upper limit will be infinity. So this integral will be integral from 1 to infinity f of x dx. Now split this integral as integral 1 to 3, then 3 to infinity. So that from integral 1 to 3, which comes in between -3 to +3, f of x can be replaced by kx square. In the other integral, f of x will be 0. So the second integral will be 0, only the first integral to be calculated by keeping k outside the integral sign. K into Integral of x square with respect to x from 1 to 3. K is 1 by 18. Integration of x square is x cube by 3. Difference at the upper limit 3, lower limit 1. So 1 by 18 into 3 cube is 27 by 3 means 9. Minus 1 by 3. 9 minus 1 by 3 which is 26 by 3. So 1 by 18 into 26 by 3 will give you 13 by 27. Probability that x will be less than or equal to 2. Upper limit is 2, lower limit is minus infinity. So integral from minus infinity to 2 f of x dx. Now split this integral from minus infinity to 2 as integral from minus infinity to minus 3, then integral from minus 3 to plus 2. So that minus 3 to plus 2 comes between the interval minus 3 to plus 3, since 2 is less than 3. So in this second integral f of x is replaced by kx square. In the first integral the integrand f of x is 0. So the whole first integral will be 0, only the second integral. For calculation, keep k outside the integral sign. Integral from minus 3 to plus 2 x square dx. And integration of x square is x cube by 3. So difference of that x cube by 3 at the upper limit 2 and the lower limit minus 3. K is 1 by 18. So 1 by 18 into putting x as 2, 2 cube by 3, 8 by 3 minus putting x as minus 3 cube minus 27 by 3 means minus 9. So 8 by 3 minus of minus 9 plus 9. 8 by 3 plus 9, denominator will be 3, numerator 8 plus 27, 35. 35 by 3 into 1 by 18, 35 by 54. Remember, all these probability values must be less than or equal to 1. And they are less than 1. Next question. Find the value of k such that f of x is equal to kx into e power minus x for x greater than or equal to 0, less than or equal to 1, 0 otherwise. Find this k value so that this function f of x is a probability density function. Also find the mean. So if this function is a probability density function, what must be the value of k? Clearly x is a continuous random variable as it takes values from minus infinity to plus infinity. That minus infinity to plus infinity is subdivided into two subintervals 0 to 1, then all values greater than 1, all values less than zeros. So x clearly varies from minus infinity to plus infinity. So x is a continuous random variable. So if f of x is a probability density function, then integral of f of x with respect to x from minus infinity to plus infinity is 1. Now split this integral from minus infinity to plus infinity as minus infinity to 0, then 0 to 1, then 1 to infinity. Sum of three integrals, integral from minus infinity to 0 plus integral 0 to 1 plus integral 1 to infinity. So that in the integral from 0 to 1, f of x can be replaced by kx into e power minus x. And in the other two integrals, integral from minus infinity to 0 and integral from 1 to infinity, f of x can be replaced by 0. So that the first and third integral are zeros, only the second integral remains for the calculation. Right hand side is 1. Keeping that k outside the integral sign, k into integral 0 to 1, x into e power minus x with respect to x is 1. So k into, now this integral of x into e power minus x with respect to x. Apply Bernoulli's generalized rule of integration by parts, taking the first factor as x, second factor as e power minus x. So that it will be first factor x multiplied with integral of the second factor. Integral of e power minus x is minus e power minus x minus derivative of the first factor and integral of the second factor of the preceding term. So while writing the second term, look at the preceding first term. Take the derivative of the first factor x, which is 1. Take the integral of minus e power minus x. Integral of e power minus x is minus e power minus x. So integral of minus e power minus x is e power minus x. Now the first factor is a constant in this second term whose higher order derivatives are zeros. So since derivative of 1 is 0, so next term and all the succeeding terms are zeros. While applying integration by parts, the generalized rule by Bernoulli, you have to use that integration by parts till that term where the first factor you get it as a constant. So here you can stop with these two terms, you can stop with that integration by parts. Take the difference of this at the upper limit x is equal to 1, lower limit x is equal to 0 and right side will be equal to 1. Keeping this minus sign outside the bracket, minus k into. Inside the bracket it will be x into e power minus x plus e power minus x. Difference of that at 1 and 0. Right side will be 1. Minus k into. Put x as 1. It will be e power minus 1 plus e power minus 1 minus put x as 0, first term 0 and e power 0 is 1. Right side will be 1. So e power minus 1 plus e power minus 1, 2 times e power minus 1 and minus 1. So it will be minus k into 2 times e power minus 1 minus 1 equal to. So taking this minus sign inside the bracket, or from this you can write what is k equal to 1 divided by minus of 2 into e power minus 1 minus 1. Taking that minus sign inside the bracket, it is 1 divided by, when minus is taken inside the bracket, within the bracket the negative term becomes positive and positive term becomes negative. So it will be plus 1 and minus 2 into e power minus 1. So 1 divided by 1 minus 2 into e power minus 1 is k. Then the mean. Mean for continuous probability distribution formula is integral minus infinity to plus infinity x into f of x dx. Now to substitute for f of x. You split the integral from minus infinity to 0, integral to from 0 to 1, integral from 1 to infinity. So that in the second integral from 0 to 1, in place of f of x you can write kx into e power minus x. And in the remaining two integrals f of x will be zeros. So the first and third integral will be zeros. Second integral. Keeping that k outside the integral sign, k into integral 0 to 1, x into x means x square, e power minus x dx. K into. Now again apply Bernoulli's rule of integration by parts with the first factor as x square, second factor as e power minus x. So first factor x square into integral of e power minus x is minus e power minus x minus derivative of the first factor, integral of the second factor of the preceding term. So to write the second term, look at the first term, derivative of the first factor x square is 2x into integral of minus e power minus x is plus e power minus x plus next term. While writing the third term, look at the preceding second term. Derivative of the first factor 2x is 2 and integral of e power minus x, the second factor is minus e power minus x. Now the first factor in this third term is a constant. So all the succeeding terms in the integration by parts will be zeros. So you can stop that integration by parts with this term. Take the difference at the upper limit 1, lower limit 0. So before you take the difference, you simplify the bracket and write. You can keep one minus sign outside the bracket. So minus k into, within the bracket it will be x square into e power minus x plus 2x into e power minus x plus 2 into e power minus x. Difference at the upper limit x is equal to 1, lower limit is 0. Minus k into, put x as 1, e power minus 1 plus 2 into e power minus 1 plus 2 into e power minus 1 minus, put x as 0. So first term will be 0, second term will be 0, then 2 into e power 0 is 1. So 2 into 1 is 2. So this will be the value of the bracket at the upper limit minus 2 will be the value of this bracket at the lower limit. So minus k into, this will be 5 times e power minus 1 and minus 2. That 0 to 1 comes between 0 and 2. So in the integral from 0 to 1, f of x can be replaced by x. In the other integral, f of x will be 0. So the first integral will be 0, only the second integral remaining for the calculation. Keeping k outside the integral sign, k into integral 0 to 1 x dx, and integration of x is x square by 2. Difference at the upper limit 1, lower limit 0. K is 1 by 28. So 1 by 28 into, putting x as 1, 1 by 2 minus, putting x as 0, 0 by 2 is 0. 1 by 28 into 1 by 2 or 1 by 56 is the required probability. So in all these exercise questions, you can see the calculated probability values are less than or equal to 1. So remember, in the calculation of probabilities, probability value should be greater than or equal to 0, less than or equal to 1. Never greater than 1, and the probability will never be less than 0. Thank you.